Welcome back. So for the moment, you probably only have programmed in OCaml using the website that we have provided for this MOOC. But at some point, you may be interested in developing real-sized program using real-world tools. So we will see how to compile OCaml programs. So the first thing to know is that the extension of the file name of an OCaml source code is .ml. The OCaml language enjoys the separate compilation property, which means that we can produce an executable program in the following way. You first compile each file separately, following the dependencies. And when you have all the compiled units, you can put them together, link them together, in order to produce an executable program. To do so, you will use OCamlC, which is a compiler from OCaml to the OCaml virtual machine, or OCaml opt, which is the compiler from OCaml code to native code, which means the code that your processor is understanding directly. In the sequel, we will use OCamlC, but you can use the same commands and they will work with OCaml opt too. So imagine that you have a project with two files, a.ml and b.ml, and that b.ml uses a.ml. So first, you have to compile a.ml. The command is OCamlC -c a.ml. This command will produce two files. The first one is a .cmo file, and it's actually the compiled code. In this case, in the case of OCamlC, it's just bytecode that can be interpreted by the virtual machine. If you had chosen OCaml opt, then you will produce a .cmx file, which will contain machine code. But there is another file that is produced both by OCamlC and OCaml opt, and that's a .cmi file. It's a compiled interface, and I will come back on that in the next slide. Now you can compile b.ml using the same method. And finally, to link a.cmo and b.cmo into the same executable program, you use OCamlC -o prog to say that the output executable program will be named prog, and after that, the list of the compiled units, but in the order of dependencies. So as a.cmo is used by b.cmo, it must come before b.cmo. In fact, compilation units are seen as modules from the programming point of view. If you have a file named a.ml, then it will appear as a module A in the program. The only change in the name is the fact that the first letter is an uppercase, so the file name is capitalized. If you want to refer in b.ml to a value x defined in a.ml, you just write a.x, and it will work. So, as compilation units are modules, then we should be able to represent also the interface of a module. And that's possible if you write a file named a.mli, so I like in interface. You can define the signature of the module A that you are defining. So the content of a.mli is basically what you would have written between sig and end when you define a signature. So you will write declarations only in that kind of file. When a.ml is compiled, the compiler looks for an interface. If the programmer wrote an interface, he will use it to compile the interface. If there is no such file, it will use the inferred module interface, the one that shows everything. If you want to compile interfaces separately, you can do it. Just have to provide an a.mli file to the compiler. It will detect that it is an interface and produce a .cmi file. This operation can be interesting if you want to parallelize a lot the compilation, because once the compilation of the interface of A is done, you can compile both the implementation of A, but also, in parallel, the implementation of B, since this compilation is using only the compiled interface. You may wonder, especially if you have programmed in the C language or in Java, what is the entry point of an OCaml program? The answer is simple. There is no such thing. There is no entry point. There is no main function in an OCaml program. The evaluation of a program is the evaluation of the modules that compose this program. And they are evaluated in the order given at the linked time, so the order that you gave to OCaml-C when you produce the executable program. And that's all. As in any programming language, you can aggregate compilation units into a single file called a library. To do so, you use the -a command of OCaml-C, followed by the list of files that you want to put inside your library, and afterwards you just use the -o option to define the name of the library you want to use. The file extension for libraries in OCaml is .cma. If you defined a native code library, it's a CMXA. Now, once you have a library, it can be used by another program, exactly as if it were a compilation unit. To install a library in the system, you just have to copy the compiled files .cmi, .cmo, and .cma into some directories that you choose to install your library. After that, if you want to be able to use the library to compile another program, you just use the option -i followed by the name of the directory in which the library is installed, and you will get all the exported values and modules that are available in the library. When you produce the executable program, you also need to provide the library as an input to push it inside the executable program. To do so, you use again the -i sumdir to configure the compiler to explain where it can find the library files, and you have to provide the library file too. This can be a bit exhausting to do all that command line, to all that configuration for all the libraries that you use in a program. Fortunately, there exists a tool called FindLib that will automate some generation of the compilation options that you want to provide to OCamRC. Also, FindLib will take care of finding a place where to install library and indexing the libraries that are installed in your system. OCaml comes with a build system tool named OCaml Build. Its role is to build, compile libraries, executable programs. Anything that can be produced by the compiler of OCaml can also be produced by OCaml Build. What is interesting is the fact that OCaml Build computes for you the dependencies between the modules. It is also configurable using a file that will describe, for instance, the libraries that you want to use to compile your program. To do so, it, of course, interacts with FindLib. And if there are some aspects that you want to do that are very specific to your project, it is also customizable using plugins that are written in OCaml. But most of the time, when you have a simple program, like for instance just a bunch of ML files that you want to compile, and a module, for instance a.ml, that corresponds to what should do your program, then just by typing OCaml build a.byte will compile a.ml with all its dependencies and produce an executable program. At another level, OCaml has a package manager, and it is called OPAM. I won't describe its use, but you can go online and you will find enough documentation to install it and to use it. A package is a bunch of libraries and programs and files that are useful to other developments. So it's a way to build on top of the work of other people your project. So it's a way to be very productive. And OPAM gives you a nice, very nice tool to be able to get all the packages that have been developed by our community. Of course, maybe someday you will be able to define your own package, your own project written in OCaml, and contribute to our community of programmers. So thank you a lot to have followed this course. And now we hope you are ready to tackle your first challenge, the project.